Hi, I'm Roberto and I'm going to teach you some physics. I might have fallen asleep after eating a pizza and today was a good day even though I had 8 hours of lab. The lab went well. The facts, the morning experiments were about density and the afternoon experiment about density. No, viscosity. Morning debate was Archimedes' principle. Archimedes' principle. That says in the more simple form that all solids that partially or totally into a fluid experience an upward force, which is equal to the weight of displaced fluid. What does this mean? So if you consider a piece that enters into, this is a container like a glass, and this is water, right? And this is a solid. If when the solid gets into the fluid, it has to push away the solid, and then the fluid to enter, and then the fluid pushes back the solid. Okay, that's basically the idea. We can understand the Archimedes principle as as a consequence of action-reaction principle, the third law of Newton. Was discovered before Newton, when Newton wasn't even born. So Archimedes' principle was itself a principle before Newton's. Okay, so the idea is that the weight of displaced fluid, as I told you, this is our solid. This solid, right? So it has to displace, it has to push away a portion. Which portion? Exactly its volume. Okay, let me do it. Exactly its volume, but of water, not water. Okay? But it has to enter into the fluid, so it has to push away a quantity of water. So Archimedes' principle says that the weight of this water is the force that pushes the solid upwards. Okay, so the weight of displaced fluid, Newton was introduced the idea of force and weight. Okay, force, we will see, I think we did, yes, force was mass times acceleration. Remember the experiment where I recorded of a solid, and we did it, I think, I'm pretty sure, but not completely. So this is the weight, force times acceleration. In the gravity field, okay, this is the Earth, so all solids follow with the same acceleration, called this acceleration of gravity. So the weight in the gravity, the force due to the mass of Earth, this force, okay, takes this form, mass acceleration, and this acceleration is the acceleration of gravity, which is roughly was a constant. Well, it was discovered that not only in the first decimal. Okay, g is more or less 9.8 meters per square second. Where I am is really 9.81 meters per second squared. Okay, so the weight of displaced fluid must be so this force, this upward force, is going to be the weight of displaced fluid is going to be the weight of displaced fluid, okay, mass of displaced fluid, it's not mass of the fluid, because mass of the fluid is not relevant, it's the one that is displaced, but pushed away by the solid. Okay, this is mass of displaced fluid. So we can do some transformations with this mass of displaced fluid that applies in the Archimedes principle. I think we can apply the definition of density that we saw yesterday. Density is mass divided by volume. If I apply it to the fluid, the displaced fluid, we'll take everything in the form mf. I can solve this equation. Mf, if I multiply by Vf in both sides, Vf will cancel, so that's all just what solving an equation means. Mf is going to be rho f Vf. So if I substitute here, I will have rho f Vf times gravity. So what's really Archimedes discovered, okay, or is thought that he discovered, it's not very quite clear, was that when you enter a solid into a fluid, put it inside, the level of the fluid rises. How much exactly? The volume of the solid. I think kind of intuitive, you have this intuition every time you introduce a biscuit into a glass of milk. So you know that the level rises. So at early age, you might have discovered that. I remember discovering when I had this glass of milk with cocoa powder, okay? And here I loved this kind of madeleines that we eat in Spain. But instead of butter, we use oil, sunflower oil. And then I discovered that when I put it inside, the milk went out of the glass, So you have to be careful to drink first before putting it, Yeah. So that's the idea. The volume of displaced fluid would be this, the amount of the fluid that rises, okay, is going to be exactly the volume of the solid, okay? Vf is Vs. So if I substitute it here, I will get it. Rho f Vs times G, okay? So if I take the beginning and the... So, no, I don't have to take the beginning and the end. What I have here is that this aqua force, which is the displaced fluid, mfg is going to be density of the fluid times gravity times volume of the solid. That's the basic equation, okay? So the buoyancy force depends on the density of the fluid, which is rho f, density of the fluid. Displaced fluid, yes, but in this case will be the density of the fluid because it's the same.